so far I talked about calculating the areas under curves above x-axis between two vertical lines. But how about the areas of curved figures, like ellipse or whatever? Let's calculate the area of an ellipse. Now, this is our ellipse. Okay. This is its equation. X squared over a squared plus y squared over b squared equals 1. And this is a, this is minus a, b minus b. Okay, now the area of this equals to the area of the upper part plus the area of the lower part. Okay, and the area of the upper part is what? Is the area under this curve, the upper curve, between these two vertical lines. Okay, x equals a and x equals minus a. Okay, so let's calculate it. We should, the x from minus a to a is the area of the upper part. I mean this area. Okay, and what is y from here for the upper part? Y equals to minus a b over a, the square root of sorry, a squared minus x squared. And this is y for the upper part and the y for the lower part. This is not a function. This relation is not a function because for x it gives us two values for y. So this is for the upper part. We actually divide it into two curves. The boundary of this ellipse, we divide that into two curves, and each of them is a function. This is the upper curve from minus a to a, is the first curve, which itself is a function, and the lower one. Okay, and the relation for the upper curve is this, and the relation for the lower curve is 1. So we calculate that later. Okay, and this would be equal to pi AB over 2. And how this becomes equal to that? It is the methods of integration. I talk about that in later videos. Okay, and now this is the area of this upper figure or upper part is this. How about the lower part? Again, the integral of the lower part is this, because this is the equation for the lower curve. Okay, so but this is negative. This equals to the negative pi AB over 2. Okay, but the area of this equals to the absolute value of this integral. Okay, so we got 2 pi AB, this is pi number, pi AB over 2, so the whole area would be pi AB. Okay, and you know, generally if we got figure like this, for instance, we should find 2 points for which, you know, this and this, for which they divides the boundary of that figure into 2 curves which be functions. You know, this is the graph of a function, you know, and this is also, because for each value of x, you know, let me draw it by, okay, the red one for each value of x got one value for y, let's call that f1x, y equals, again out of screen, y equals f1x, and the lower curve, let's call that y equals f2x. Okay, and now draw these vertical lines, and now the integral of f1x dx, let's call that a and this b, from a to b, equals to what? Equals to the area under the red curve, okay, which is this. Under the red curve between a and b and above the x-axis, okay? And what is f2x dx, the integral of f2x dx from a to b? It is the area under the blue curve, which is, you know, this is this area of this. Okay, now this, the area of our figure, is the difference between these two areas, the whole area minus this area, so that would be equal to this minus this, which itself equals to the integral of from a to b f1x minus f2x dx. Okay.